Okay, for those just join, okay, remember to fill out the attendance. Okay, so it's in the chat. You scroll go up. Okay, today we start with the discuss your assessment for. Okay, so how to say? I have marked and then written to you already. Okay, so you can check. Okay, so I have to. Okay, so this is the questions. Okay, this is last week, right? Last Thursday, you sit for this test. Okay, arrange 7 girls to sit in front row of a photo shoot. Find the number of different ways the girl can be seated if there are no condition. Okay, no condition, very simple. 7 of them. Okay, can see the questions, right? Someone on the mic?
Yes, can see, teacher.
Yeah, okay, thank you. Okay, so when no conditions, you arrange 7 of them, arrangement, so is the P, okay, if not you use the factorial, okay? So 7, okay, factorial. Okay, so you press calculator, you get the answer 5040. Okay, this is 2 marks. By writing 7 factorial is 1 mark already. Then final answer 5040, 1 mark. Okay, next. Okay, Aisha and Mei Ling are separated by 3 other girls. Okay, so this one I have to draw a little bit. This is the Aisha and Mei Ling. Okay, let's say this is Aisha. So separate by 3 other girls, 1, 2, 3, and then only Mei Ling. Okay, altogether 7 of them. So this is 3, 4, 5, okay, 6, 7. Okay, so the first arrangement will be this way. Okay, second arrangement is Aisha go to at the second one. And then first one got somebody, and then again in between 1, 2, 3, 3 other girls, separate these 2, and then Mei Ling, okay, and then 1 girl. Okay, count and see, is it got 7? 3, 4, 5, 6, 7, correct. Okay, then the third one can be, okay, in front Aisha got 2, okay, and then only Aisha, and then separate by 3, 1, 2, 3, and then go to Mei Ling. Okay, so 1, 3, 4, 5, 6, 7. Okay, so there are 3 possibilities. Okay, so your answer have to be 3 times because of these 3 possibilities. Okay, and then 3 times what? Okay, you see these are empty space, you just put any of them here. So this is a 5-way, 4, and then 3, and then 2, and then 1. Okay, so this is 5 factorial. Okay, after that, okay, the A and the M, the Aisha and the Mei Ling, they can interchange. Okay, means first the Aisha sit here, then after that the Mei Ling can sit here and then Aisha sit here. So 2 more way times 2. Okay, so this is the answer 720. Okay, so this is for 1B. Okay, 1B also same thing, 2 marks. Okay, now we go to number 2. A chairman, a secretary, 4 committee members of a science society will be selected from 10 students that included a set of twins. I think this is trying to disturb you only, a set of twins. Nothing to do with the set of twins because they didn't give any conditions about the twins. Okay, if a student has been appointed as a chairman, okay, so means already one is chosen. That one you don't care already. Okay, means this one also come and disturb you. Okay, and then because 10 students one already chosen or appointed as a chairman, so you got to -1 here. Okay, so the balance is 9 students. Okay, so the question it should be, okay, out of the 9 students, okay, find the number of ways to choose So you should use C, choose a combination, don't use permutation. Okay, to choose a secretary and a 4 committee member. Why you don't use permutation? Because here the sequence of the arrangement is not important. Okay, so you use a combination C. Okay, so find the number of ways to choose a secretary. 9 out of the 9 students. Okay, so first of all, 9 of them you choose one. Okay, to be the secretary. Okay, after that, okay, you still have the balance of 8. Okay, after you choose one to be the secretary already, okay, 9 minus 1, so now the balance of 8 students. Out of the 8 students, you choose, okay, 4. Okay, so this is the answer. Okay, so the answer is 630. Okay, this is 2 marks also. Okay, now we look at number 3. Okay, so this is 8 orchids, 6. Okay, this is what begonia. Okay, and then 4. This is what pinutia. Okay, so Madam Lim wants to buy 3 orchid, 4 begonia, and 2 petunia. Sorry. Okay, so find the number of ways Madam Lim can buy the flower. Okay, same thing. Okay, out of the 8, you choose 3. Okay, this is orchid and orchid. Out of the 8, you choose 3. Okay, so this is combination. Because how you arrange them is not important. You just choose. Yeah, so 8C3 for the first one. Okay, then for the begonia, 6 you choose 4. So 6 you choose 4. Okay, then last petunia. So 4 you choose 2. Okay, so the answer is 5040. Okay, so same thing, this is also 2 marks. Okay, now we go to 3B. This one, you want to hang the pots of flower in front of her house in a straight line. This one is arrangement. Okay, arrange. Okay, this one is permutation. Okay, means the sequence it is important, how you arrange it. Okay, she wants to arrange in a way so that the 3 pots of orchids are in the middle. Okay, so this is fixed. Okay, 3 pots of orchids. This one, okay, is in the middle. Altogether, how many pots? 3 pots of orchid, and then 4 of begonia, and then 2 of petunia. So 4 and 2, the balance, so 6. So here must be another 3 pots, here another 3 pots, so that the orchid only will stand in the middle. This is how she going to arrange. Okay, so what is the meaning of this? Okay, this one is fixed, so this is only one way, so we don't care about this already. Okay, so 1, 2, 3, 4, 5, 6. Okay, so this is 6 way, 5, 4, and then 3, 2, and then 1. Okay, therefore this is 6 factorial. Okay, and then remember that among these 3 pots of orchids, it can be rearranged. Okay, so here we have a 3 factorial. Okay, so this is the answer already. Okay, so 4320 is the answer. Okay, same thing, another 2 marks here. Okay, if any question, you can stop me anytime. Okay, for question number 4. Question number 4, maybe I do it here. Okay, so we start with 6CR. Okay, 6CR, you follow the formula is 6 factorial. Okay, 6 minus R factorial, and then R factorial. Okay, equals to, okay, 5 times 4CR. So 5, okay, times 4CR is 4 factorial. Okay, and then 4 minus R factorial, R factorial. Okay, so the first step, this one can cut. Okay, and then I try to combine these two. Okay, 4 factorial times 5, so I have a 5 factorial here. Okay, then the 6 factorial, I try to break it out, so becomes 6 times 5 factorial. Okay, the purpose is to get rid of the 5 factorial. Okay, next, I have a 4 minus R factorial. Okay, this one I keep. Okay, 6 minus r factorial, I break it out. Okay, so start with 6 minus r. Okay, 5 minus r, and then 4 minus r. Okay, I'll stop here, followed by the factorial. So that this and this I can cut, this and this I can cut. Okay, so my equation now become 5 minus r equals to 1. Okay, become this way. Okay, so this one bring to this side. Okay, so divide become times 1. So I have a 6 minus r, 5 minus r equal to 6. Okay, this one I expand. So 30 minus 5 minus 6 minus 11. This one bring this side minus 6. Okay, rearrange. Okay, group this. 30 minus 6 is positive 24. Okay, do the factorization. So r minus 3, r minus 8. Okay, you have a 2 answer here, but you got to reject this. Okay, because you look at the questions. The question is 6CR, 4CR. The R cannot be bigger than 4. Okay, so this one you got to reject. So this is the answer. Okay, so this is 4 marks, this question. Okay, now we go to question number 5. Okay, 5 train carrier. Lisa and the 2 brothers and their parents. So altogether 5 of them. Okay, find the number of way if Lisa father write in the carrier 1, mother write in the carrier 5. So this is fixed. Okay, father is here. Okay, and then mother is here. This is fixed. Okay, so means Lisa and the 2 brother, okay, can be arranged in the carrier 2, 3, and 4. Okay, therefore is 3 factorial. Okay, for the A, number 5A, this is 3 factorial. So the answer is 6. Okay, this is 1 mark only. Okay, then part B will be 2 marks. Okay, mother and father were sitting on the first 2 carriers. Okay, means mother and father. Okay, it here can be mother, then father. Then it can be here father and then here mother. Okay, so you have to times 2 in this case. Then after that 3, 4, 5, same thing. Okay, the Lisa and the 2 brother. Okay, so 3 factorial. Okay, so 6 times 2. So this is 12. Okay, here is 2 marks. Okay, now last questions already. Okay, look at number 6. Okay, state the value of x and then C1 in terms of the x. Okay, so you see xC1. Let us see for the 5C1. You press calculator. 5C1. Okay, I'll call the calculator and see. C1. You get 5 should be, okay? And see, okay, how about 8C1? I think you get 8. Okay, can okay, so anything C1 you get that thing. Okay, so this is you get 5. Okay, and then more example lah. Okay, therefore the xC1 you are getting x. So this is only 1 mark. Okay, for number 6B. Okay, vertices of the an octagon. Octagon is 8 sides. Okay, so after 8 you choose 3 because triangle you need 3 vertices. Okay, so 8 you choose 3. Okay, so that you can form a triangle. Okay, so 8C3 for this question. So answer is 56. Okay, this is 2 marks. Okay, that's all for your assessment 4. Okay, now we come back to your textbook. Okay, may I know you have any question to ask or not for the exercise 6.5? And then maybe 6.4, I'm not sure. 6.4, 6.5. Any question to ask? Yeah, Melissa? Cannot hear you, too soft.
1B, open C.
You type. Okay, Xingzi asked question 6B, I do correct, but you give me wrong. 6B. Yeah. Xingzi, I already changed in the marks in the assignment. And then in the assignment, you go and see the turn in. Okay, I have put a remark for you. Okay, Vanessa want to ask 6.5, 1B3. 6.5, 1B3. 1B3. Okay, the modulus one, 6.5, 1B3. Okay. So which method you want me to show? The using table one, or you know, the other one? Okay, the first one that we learned. Which method you want me to show? Table. Question 1B. Third one. Minus 1. Okay, so if this is you want to use table, okay, interval is the 90 divided by the b, but the b here is 1, okay, so 90 divided by 1, so it's 90, okay, so you use the interval of 90. Okay, these questions are the range is in pi, radian. Okay, so you build the table. 90 degree is pi over 2. Okay, so I will start with the degree. After that, I will write the pi in pi form also. Okay, 90 degree, then 180 degree, 270 degree, and then 360 degree. So this is 0, this is pi, this is 2 pi, this is pi over 2, this is 3 pi over 2. Okay, then we try to use calculator to help. Okay, the first one is 0. The first one is x is 0, so tangent 0. What do I get? Okay, I get 0. So 0 minus 1. Okay, I get -1. So here I get -1. Okay, for the 90 degree, tangent 90 degree. Okay, this one I get infinity. Okay, so here this one after I need to test. Okay, 180 there. Tangent 180. Okay, this one I get 0, so 0 minus 1, so -1. Okay, I think this one I get infinity. Let us try tangent 270. Okay, then 360. Tangent 360. Okay, this is 0, so 0 minus 1, so -1. Okay, so I have to test the a bit before the 90 and a bit after the 90, same as 270 lah, huh? Okay, and then the asymptote is fall at 90 and 270 lah, huh? Okay, so let's say I try for 90, I try for 89, and then one is 91. Okay, so tangent of 89. Okay, 50 something. Okay, modulus it positive, so 50 something minus 1, so 56. Okay, point something lah. Okay, then for 91. So tangent 91. Okay, tangent 91 is a negative 57, but with the modulus, it becomes positive. So it's become 57. So 57 minus 1. Okay, so it's 56. So it's same as this 89. Okay, so both are at the positive side. Okay, so 56.229. Okay, this one same thing, I write 29. Okay, if you want to test for 270, actually I think the same thing. Let us try. Never mind. Okay, because very fast only. 270, a bit before is a 269, a bit after is a 271. Okay, so tangent 269. Actually, it's just important you get either positive or negative. Okay, so you see you get the same thing. Okay, 57. Okay, so minus 1, so 56. Okay, I think 271 the same thing. Tangent 271. You're getting negative, but because of the modulus, so you change to positive. So this one's still the same thing. Okay, so you are gather your information done already. So now you can start to sketch. This one is draw, huh? Draw, you have to use a graph paper, huh? I don't know whether you use a graph paper or not. Okay, this one you should use graph paper, huh? Because the question say draw. Okay, and then if you are using graph paper, actually more accurate, I can say, is by using the table law. But never mind, the other method also can be used. Okay, so here I put 90, 180, 270, and 360. 0, pi over 2. Because in a radian, so this one you don't write 90, you write pi over 2. And 2 pi. Okay, now draw the asymptote at the pi over 2 or the 90 degree. Okay, and the 270 degree, draw the asymptote. Okay, and then you need the negative 1. This is very important. This negative 1 will give you mark. Okay, so now 1 point is here, 0, negative 1. Okay, and then slightly before the pi over 2 is 50 something positive. So it's going up this way. Going up this way. Okay, and then at pi is again at the negative 1. Okay, but slightly after the pi over 2 is infinite positive, so this way. Okay, and then here also is positive, so this way. Okay, then 2 pi, again this is negative 1, here also is positive, so this way. Okay, so this is the answer. Okay, Vanessa, you got more question to ask? Cannot hear you lah. Your voice is breaking. Huh? Again.
I type.
Cannot hear. You on your mic, talk slowly, and off your mic. Okay, you type. Type. Okay, no question. Thank you. Okay, if this is okay, then we'll go to a new subtopic already for today. Okay, basic identities. Okay, look at your textbook page 211. Okay, this is the index for today. Okay, basic identity. I'm not sure this basic identity is given in the formula list. Let us check. Here, 13, 14, and 15. Okay, these three are the basic identity. Come back here. Okay, so this one you can copy as your notes. Okay, basic identity, these three. Okay, but you can put a remark. This is given in the formula list. Okay, what's the meaning? Okay, a trigonometric identity is what? Okay, is an equation. Okay, this is an equation, got equal sign, that involve trigonometric function and is valid for any value of angle. This one. Okay, is valid for any value of the angle. No matter what's the value of this theta is also valid. This is the meaning. Okay, so this is a trigonometric identity. Okay. Three more okay, and then this three identity, these three just now you copy one, this three is we call it Pythagorean identity. Okay, so now I want to prove this three identity. Okay, we start with this triangle. Okay, the proof one you must know. In case they ask you to prove the basic identity, you must be able to prove it. Okay, so whether you want to write in your books or not is up to you. Okay, the proof okay, but you must know how to prove the basic identity. Okay, so we start with this. Okay, we start with this, the right angle triangle. Okay, so your tuakaso. Okay, you label the how to say the length okay, and the vertex. Okay, or we can say the angle. Okay, so if here is the angle A, okay, then the opposite one you label the small a. Okay, here the angle B, then the opposite one you label as small b, and then here is the C. Okay, so we start with let's say we are doing for this angle A. Okay, so the tuakaso. Okay, so this is opposite. Okay, this is a hypotenuse, and then this is the adjacent. Okay, so sine A is so O over H, so A over C. Okay, A over C. Okay, cos is car, so A over H. Okay, so A over H, so B over C. Okay, tangent is 2R, so O over A, so A over B. Okay, then cosecant A as a reciprocal of the sine A, so terbalik, so A over C becomes C over A. Then second is the reciprocal of the cos, so B over C becomes C over B. Then cotangent is the reciprocal of the tangent, so A over B become B over A. Okay, so get ready of these 6. Okay, after that, because you know that just now we say this is a Pythagorean identity. Okay, so they are using the Pythagoras theorem. Okay, so Pythagoras theorem, because this is a right angle triangle, so the a squared plus b squared is equal to c squared. Okay, we start with this. Okay, then, okay, you do what? Okay, you see here. Okay, divide the two sides of the equation by a squared, b squared, and c squared. Then you will get the, okay, the basic identity. Okay, we do one by one. Okay, when you divide, okay, the a squared plus b squared equals c squared, divide by a squared. Okay, every term you divide by a squared. This is what you're going to get. Okay, and then B over A, you refer back. B over A is what? Cotangent A. Okay, fair enough. See? B over A, okay, cotangent A. Okay, so replace the B over A with cotangent A. Okay, because here got square, so the square you write here. We don't write in this way, we don't write in this way. We don't write in this way. Okay, we will write the thing, the trigo with the square. We'll write the square here, the 2 here. Okay, so this one we don't write in this way, okay, so you have to know what's the meaning of this these 2 here. Okay, then C over A. Okay, we refer back to the list just now. C over A. C over A is here. Okay, so it's cosecant. Okay, so replace it with cosecant. Okay, cosecant square. Okay, so this is one of the identity. Okay, after that, if you divide, same thing, A squared plus B squared equals C squared. Okay, divide every term by B squared. Okay, so this is what you're going to get. Okay, then you find A over B is what? Okay, A over B is tangent A. Okay, so this one replace is with tangent A. C over B leh? Is it second A? C over B second A. Okay, so you see, replace it with second A. Okay, so last one. Okay, divide by C squared every terms. Okay, so this is what you get. And then A over C. Okay, A over C is sine A. Okay, so replace it with sine A. And then B over C. Okay, B over C is cos A. So replace it with cos A. So not difficult. Okay, so you remember basic identity for these 3. The other name, they also call it Pythagorean identities. Then you know that you need to use a Pythagoras theorem to prove it. Okay. Okay, so this is how you prove these 3 identity. Okay, straight away we look at the example how we use this identity. Okay, without using a calculator, find the value of each of the following. Okay, look at this. Okay, sine square negative 430 plus cos square negative 430. Okay, this one you use this identity. A cos A. Okay, this one is equals to 1. Okay, as long as this and this the same. Okay, sine square plus cos square, your answer should be 1. Okay, so this one the answer is 1. That's all. Okay, this is how you use a basic identity to help. Okay, you to solve the sum of the problem. Okay, then how about this tangent? Tangent, okay, the identity that I have is this. Okay, so tangent minus second, so this is plus. Tangent minus second, so tangent, I keep it here. This one come to this side minus second. Okay, the 1 come to the other side become negative 1. Okay, so tangent squared minus second squared, the answer is negative 1. So negative 1. Okay. Okay, so this one will be your homework. Okay, but I go through a little bit with you. Look at this number 2. Number 2. Okay, if previously, before you learn this basic identity, you may use this method to do. Okay, once you see this, you will draw the right angle triangle, right? Okay, then the m is m over 1. Okay, let's say this is theta. Okay, so this is car. Okay, so this is opposite, adjacent, and hypotenuse. So m over 1 is a over h. So here is m, then here is 1. Okay, then find the other length. So by using this, okay, the hypotenuse, so 1 squared minus the m squared, something like this. Then you will continue. Okay, second square x is second square theta is what? Okay, is equal to 1 over cos square theta. Okay, then this one is equal to 1 over square theta is m, so m squared. Okay, then this one you will use what? sine theta, sine square theta. Okay, sine is what? So O over H. So is this over 1. Okay, then square it. So the answer is 1 minus m squared. This is what you're going to do, okay, before you learn this basic identity. But now you have learned this basic identity, how about we try to make use this basic identity to help you, okay? This one, I think got no problem. This one, I don't use this triangle, also no problem, okay? The second square x, I just write as a 1 over cos square x, and then cos theta is m. So 1 over m squared. Okay, but how about this? If I don't want to use this, I don't want to use this triangle method already. Okay, what is this? Sine square theta. I want to use a basic identity to help me. Okay, so you see, we know that sine square A cos square A equals to 1 ma. Okay, so sine square A means this one I move to this side is equal to 1 minus cos square A. Okay, so this one you can write it as 1 minus cos square theta. Okay, then cos theta is here is m. Okay, so square, so m squared. See, same answer. But this one, you don't base on this triangle method to help you. Okay, you use a basic identity to help you. So there are two ways of doing Okay, so all this for this exercise you try to use a basic identity to help you Okay. Okay, so I leave it to you. Hope you can do. Okay, now we go to this. Okay, proof. This one is a little bit difficult actually for most of the students. Okay, but you just need to do more questions. Okay, actually. Okay. So proof trigonometric identities by using the basic identity. Okay. So what is the meaning of the proof? Proof means you have to form the either left hand side. You start with the left hand side. Okay, you do until you see your answer as the answer on the right hand side. It's not the other way around. You start from the right hand side, then you do, then until you see the answer on the left hand side. Okay, either one. Okay, so the tips here is very good. Okay, you can we go through now. Okay, to prove the trigonometric identity, prove from the more complex side. You check the two sides. You think which one is more difficult, more complex. You start with that one. But sometimes both sides also equivalent. Then you start with either one also can, no problem. Okay, if you can see any of the side is more complicated one, then start with the more complicated one. It's like, you know, you reduce it, you simplify it to reach another side, the answer. Okay, B, convert to a basic trigonometric ratio form. Okay, if you can convert, okay, try to convert to the basic trigonometric ratio. Okay, ratio means like, you know, you have this type of ratio, sine A over cos A, you know, all these things. Okay, and then sometimes you also can multiply by a conjugate. Okay, multiply by a conjugate means the denominator and the numerator you multiply with the same thing. Okay, the conjugate. Okay, so let us see the example 18 here. Okay, the A. Okay, how do we prove it? Okay, you see this the solutions. So it starts from the left hand side. This is left hand side. Okay, and then you do until it reach the right hand side. Okay, how to start now? So left hand side we start with 1 minus 2 sine square A. Okay, the sine square A. You look at the right hand side, no more sine square A, but it become cos square A. So I must use an identity that sine A plus sine square plus cos square equals to 1. Okay, so I replace the sine square here with the 1 minus cos square, because this one, the plus, both this side become minus now. So 1 minus cos square. You replace the sine square with the 1 minus cos square. Okay, expand it. This is what you get. Rearrange it. Okay, so you get the answer as the answer on the right hand side. Then you just write proven. Okay, not difficult, huh? Okay, we look at example B. Okay, tangent, cotangent, second, cosecond. Look like nothing. Don't know how to relate them. Okay, and then some more got no square, no square. How to involve with the basic identity. Okay, this B, you try to use this, the tips here, the B. Okay, let us start. Okay, let's say we start with the left hand side. Okay, cotangent and tangent plus cotangent. So tangent, I write it as a sine over cos. Okay, cotangent, I write it as cos over sine. Okay, then combine it. Because here you can't see any plus or minus anymore. So combine these two fractions into one fraction. Okay, so when they share the common denominator, cos A sine A, so here this one had to times with sine A, times with sine A. Then here have to times with cos A, times cos A. Okay, so common denominator is sine A cos A. Then the numerator becomes sine square A plus cos square A. Then here you use the basic identity. Sine square A plus cos square A is 1. Replace it with 1. Okay, then how the 1 over cos A sine A become second A and cosecond A? Okay, because the second A is the reciprocal of the cos. And then cosecond A is the reciprocal of sine. So one more step, you just break this one into 2. Okay, put in between its times. Okay, so this one, okay, I write here. You write it as 1 over cos A times 1 over sine A. Okay, so 1 over cos A is second A. Okay, 1 over sine A is cosecond A. Okay, then you get the right hand side. Okay, so this is how you prove. Okay, actually can be done. Okay. Okay, next, I show you one more example here. Okay, you look at this. Okay, proof can be done by simplifying the expression on the left until they are similar to the expression on the right or vice versa. Okay, proof is also, okay, look at this. Proof is also possible by simplifying the expression on the left and expression on the right until both expressions are the same. This method is shown in the example below. What's the meaning? Okay, means left hand side you do, right hand side also you do, okay, until you get the something. Okay, that something both sides when you do is the same thing, then you say it's proven. Also can. Okay, we look at this example. Okay, prove that tangent square minus secant square plus 2 is equal to cosecant square minus cotangent square. Oh, complicated. Okay, but don't worry. Okay, look at left hand side. Okay, tangent square minus secant square plus 2. Okay, see what we can do to this. Okay, you can see the square, straight away go back to the identity. Okay, so you see secant square minus, tangent square minus secant square. Okay, so tangent square, not equal. Okay, this one secant square move to this side minus. Okay, then the 1 move to this side become negative 1. Okay, so tangent squared minus secant squared, you can write it as a negative 1. Okay, then plus 2. So 2 minus 1 is 1. So you know your left hand side is getting 1. Okay, now you look at the right hand side. Anything that possible you can do. Cotangent, cosecant, cotangent, cosecant, cotangent and cosecant. Why they use this method? Cotangent, cosecant, I will not use this method. Just straight away use the basic identity lah. Cotangent and cosecant I have this 1 plus cotangent is equal to cosecant. Okay, so here is cosecant minus cotangent. So this one move to here is minus already lor. Therefore, cosecant minus cotangent is 1 lor. Okay, so this one all no need. Oh, no need. This one is minimum is 1. Okay, that's all. It's proven. Okay, because left hand side you also get 1, right hand side is also get 1, means left hand side is equal to right hand side is equal to 1. So it's proven. Okay, so that's all. Okay, then you try this. Must try, girls. Here 8 questions, all the 8 questions you must try. Okay, if cannot do, next lesson please ask. Please, if you want, before next lesson, you text me already which question you want to ask, so that you know during the lesson I don't need to ask you, which question you want to ask. No need. Okay, okay, I think that's all for today.